Okay, this is a test to review, and the first question is let A denote the event of placing a $1 straight bet on a certain lottery and winning. Suppose that for this particular lottery there are 2880 different ways that you can select the four digits with repetition allowed in this lottery, and only one of those four digit numbers will be the winner. What is the probability of winning? So as we can use the formula, the probability of winning is 1 out of 2880. So if you look at this answer, e to the power negative 4 means divided by 10,000. This is a scientific notation, so we can write it down as a 0.0000347. Look at here, the answer should be in decimal form, round to the 5 decimal place. So it's a 0.00034, so 0.00035, because if you round it to the 5 decimal place, this 4 becomes 5. Check the answer. And now its a complement is 1 minus this number, so whatever number we got here, if you subtract from 1, 1 minus the answer we have here, the its complement would be 0.99965. 0.99965. Remember, you have to follow the instruction the way they want us to put the answer. Here they want in decimal form, so don't put fraction form. Okay, so that's our first question. Okay, next question is, which of the following values cannot be probabilities? So we know that probabilities should be in between 0 and 1, and inclusive 0 and 1. So anything more than 1 and less than 0 is not probability. So 3/5 is less than 1. 1.39 is greater than 1, so it's not the probability. Square root of 2 is also greater than 1. If you use calculator and calculate square root of 2, it's a 1 point something, 1.41, so it's not probability. 5/3 is also greater than 1, and a negative number is not probability, so rest of the numbers are probability. Okay, so that's our question number 2. Okay, so next question is, you are certain to get a number or a face card when selecting cards from a shuffle deck. Express the indicated degree of likelihood as a probability value between 0 and 1 inclusive. If you are certain about something, the probability should be 1. It's 100% certain means probability is 1. So let's go to next question. In a particular survey of internet user, 3,574 respondents say that they use social networking sites, and 1,481 respondents say that they do not use social networking sites. What is the probability that a randomly selected person uses a social networking site? Keep in mind, for the probability, we know there is a formula. Probability of any event A is equal to number of there is a formula, number of so I'm going to just go here and give you that formula. Probability of event A is number of ways A occurs divided by number of different simple events. In this case, if you go back to the problem here, total, if you add these two numbers, you are going to get the total number. And if you want to find out the probability that a randomly selected person uses social networking, so as you can see here, 3,574 of them use the social networking. So if you add these two numbers, 3,574 plus 1,481, the total number is 5,055. Out of 5,055, 3,574 uses the social networking, then the probability would be you have to divide that 3574 by total number, which is 5055, and that gives you this probability. Keep in mind you have to always read the instruction round to 3 decimal place, so it should be 0.707. 0.707. So is it likely for a respondent to use social media? Yes, you can see that 70% or more they are using social networking according to this this survey. So yes, the answer is yes, because the probability is more than half, more than 0.5. Yes, because the probability of a respondent using social media is less than or equal to 0.5. This is not the right one. So the last one, yes, because the probability of a respondent using social media is greater than 0.5. Fill in the blank. The dash for a procedure consists of all possible simple events. That's called sample space. The sample space for a procedure consists of all possible simple events. As a procedure is repeated again and again, the relative frequency of an event tend to approach the actual probability. This is known as the law of large number. Okay, if A denotes the event of selecting someone with blue eyes, then PA means it's the probability of selecting an adult with the blue eyes, and PA bar means the probability of selecting an adult who doesn't have the blue eyes. Okay, a research center poll showed that 76% of people believe that it is morally wrong to not report all income on tax return. What is the probability that someone does not have this belief? So if 76% says thinks it's wrong, then the opposite of 76% is 100 minus 76, which is 23%. So the probability is it's a point, no, not the 23%, it's 24%. So it's a 76% in the probability is 0.76, and if you subtract this number from 1, so 1 minus 0.76 gives you 0.24. So 0.24 is the answer for this question. Okay, we have given a table here, probability distribution table. Use the data in the following table, which list drive-through order accuracy at popular fast food chain. Assume that order are randomly selected from those included in the table. If one order is selected, find the probability of getting food that is not from restaurant A. So these are the numbers from restaurant A, the first column, and then rest of the restaurant also given here. So first of all, we need to find out total number and then number from the restaurant A. So if I click here, I can copy this data in Excel, and then I can find out that number very easily. So as you can see here, I can add all this thing by using this sum notation, SUM sum notation, sum function, and I can sum from here to here. So that gives me sum of this from restaurant A, and if I just scroll it like this, then I can find out total order from restaurant B, restaurant C, restaurant D, and also I can add all these number from here to up to here. So that gives me total number of total order. So either you can use Excel or you can use calculator. That's up to you. Here I'm using Excel. So from restaurant A, there are 353 order out of 1119. If we choose randomly one of the order from restaurant A, the chance is 353 divided by 1119. So I'm going to do that here. 353 divide it by total number of order 1119. That's 0.315, and we have to round it to the 3 decimal place, so it should be 0.315. so it's a 0.315. Wow, what happened here? Did I do something wrong? So let me go back and check it again. The probability of getting food that is not from restaurant A. Sorry. So I found it from a restaurant A. This is the probability from restaurant A, but we are looking for complement of this. So we need to subtract this value from 1. That's how we find the complement, which is not from restaurant A, which is 0.6845. So if you round it to the 3 decimal place, it should be 0.685. So my bad here, 0.685. So sometime we might read a question incorrectly. So make sure that you double check it twice at least before you submit your answer. Next question. So we have this data given, and now we need to find out if two orders are selected. Find the probability that they are both accurate. So if two orders are selected, then we need to find out what is the probability of both of them are correct. So look at this table here. We can again copy this table. We can again use the Excel. Okay, so assume that the selection are made with the replacement. So to solve this problem, if you go here, the probability of let's say we want to pick two order, first order and second order, and because with replacement, when we pick first one and then again second one, they would be independent. So that's why we can find the probability of the first number times the probability of the probability of finding the second order. So in this case, as you can see here, if two order are selected, so probability of finding the first order times the probability of this finding the second order, because of this replacement they would be independent of each other. So for finding that, we have to add total number of orders and total number of accurate order. So for that, we can again do it manually using our calculator, or we can just use Excel sheet to add these all orders. So using sum command from here to here, so that gives me total number of accurate order. And if I just do the same thing for this row, that gives me total number of inaccurate order. And if I add these two number 985 and 134, that gives me total number of order. So if we use this formula, so as you can see here, the probability of the first order is how many the accurate order are there. It's 985 out of 1119. So 985 out of 1119, because after replacing the second time also, it will be the same probability, 985 accurate order out of 1119. So if we multiply these two number, that gives us probability for this part. So I'm going to just divide 985 by 1119. So that's the number we have. Look at here, 985 divided by 1119. Enter, and then multiply by the same thing. So I'm just going to square it. Square means multiply by the same thing. So the probability is 0.77, and round it to the do not round until the final answer, round to the 4 decimal place. So 0.7748 is the answer. 0.7748 is the answer, and the events are independent. For the second part, this time without replacement. Keep in mind, without replacement, when we use this formula second times, what happens is, instead of 985 cases, because we already pick one accurate order, so the leftover would be, this time the leftover would be, the first case would be the same thing. The chances of picking accurate order is 985 divided by 1119, and then second times it would be 984 because we are not replacing the first thing, we're picking it and then we're not replacing it back. So the total accurate order under our assumption, if we already picked the first one accurate order, so the total leftover would be 984 out of the leftover would be 1118 because one is already picked. So we can multiply these two for finding the answer. So one more time, it's 985 divided by 1119 times this time 984. I have to use this parenthesis, otherwise my calculator will not work properly. So okay, I did something wrong here, so let me just first 985 divided by 1119, this is the number, times it by 984 divided by 1118, so that is my 0.7747. so the answer is 0.7747 if you round it to the 4 decimal place one more time. And then the events are dependent, are not independent, okay. Okay, next question. Use the following results from a test for marijuana use which is provided by a certain drug testing company. Among 142 subjects with positive test result, there are 29 false positive results. So out of this 142, 29 are actually negative. That is the meaning of false positive result. And among 159 negative result, 5 false negative result, meaning out of 159, 5 of them were actually positive. So now we have to answer this question: how many subjects were included in the study? You just have to add 142 and 159. So it's 142 plus 159, that gives us total number of cases, total number of subjects. And how many subjects did not use marijuana? So you can see that among 142 subjects with positive test result, actually 29 of them did not use. That's a positive false. So this 29 plus out of this 159 negative, 5 subtract 5, so it would be 154 because actually 5 are positive. So it's 29 plus 154. Okay, so 29 plus 154, that is actually negative results. 183 negative means they did not use marijuana. 183. What is the probability that randomly selected subject did not use marijuana? So 183 total 301, so it's 183 divided by 301, but we need to use decimal form. So where is that? We need to use decimal form, so we are going to use this calculator here. 183 divided by 301, so that's a chance of the probability that a randomly selected subject did not use marijuana, which is 3 decimal place would be 0.608. 0.608. Okay, so that's our question number 11. So our next question is question number 12. The principle of redundancy is used when system reliability is improved through redundant or backup components. Assume that a student's alarm clock has a 19.3% daily failure rate. So under this assumption, we have to answer some of the question. What is the probability that the student's alarm clock will not work on the morning of an important final exam? So that not working failure rate is 19.3%, so that is our probability, which is 0.193. 193. That's the failure rate for a clock. But if you have if the student has two such alarm clock, what is the probability that they both fail? Remember, these two clocks are independent of each other, so their failing rate is failing rate of 1 times the same rate. So if you use calculator, it's actually 0.193 times 0.193, which is actually the square of the same number. So this is the failure rate, which is 0.0372 1 2 3 4 and then 5. So 0.03725, 0.03725. So as you can see here, if the student only uses one alarm clock, then failing rate is 19.3%. If that student uses two alarm clock, then failing rate is less than 3, it's less than 4%, it's a 3.7%. What is the probability of not being awoken if the student uses three independent alarm clocks? So instead of 2, what happens to the 3? So we have to repeat the same thing. Instead of multiplying or squaring, we have to cube it. So we can do this same thing by multiplying this number by one more time the same probability. So I'm going to multiply this number by 0.193. So meaning I'm multiplying 0.193 three times. So that is 0.00719. 0.00719. 0.00719. Okay. Do the second and third alarm clock result in greatly improved reliability? Yes, of course. Look at here, from 19.3% to 3.7% to 0.7%. So it's improving. So answer is yes, because total malfunction would not be impossible, but it would be unlikely. So that means the probability is very, very low. Okay, so this is question number 13. Let A the event of getting at least one defective calculator when 4 are randomly selected with a replacement from a batch. Write a statement describing event A bar. Event A bar means it's a complement of event A. So the event A is getting at least one defective calculator. At least one defective calculator. So its complement is none of them are defective. So the event of getting 4 defective among the 4 calculator, that's not right. The event of getting more than one defective, the event of getting at least one defective, the event of getting no defects among the 4 calculator, it's a complement of at least one of them is defective. At least one defective means it could be 1, could be 2, could be 3, could be 4. So complement of all these cases is no defects. So next question, in a certain country, the true probability of a baby being a boy is 0.513. That's the probability of a baby being a boy. Among the next 7 randomly selected births in the country, what is the probability that at least one of them is a girl? So keep in mind, if you go back to the previous problem, that tells you at least one means the complement of that is none. So here, what is the probability that at least one of them is a girl? So instead of finding at least one of them is girl means in first case it's a girl. It may be one girl, maybe two girls, maybe 3 girls, maybe 4 girls, 5, 6, 7. So complement of that is no girls, meaning all of them are boy. So out of 7 birth, what is the probability of getting boy, all the boys? First of all, we are going to find that, and we're going to find the complement of it. Okay, so out of 7 birth, probability of getting all boys is equal to probability of getting first boy times probability of getting second boy, because they are independent events, so we just have to multiply all of them, 7th boy. So we have given the probability of getting first boy, it's given 0.513. So we have to just what is that, we have to just multiply this 0.513 times 0.513 7 times. So that means probability of all boys, and then probability of at least one girl is equal to 1 minus probability of getting all boys, meaning this is the complement. At least one girl is a complement of probability of getting all boys. So we need to subtract this number from 1, which is in this case 513 to the power 7. So I'm going to use a calculator here. So it's 1 minus, let me just double check the probability given here. It's a 0.513, not 517. Okay, 513, yeah, that's right, 513. So 513, 0.513 to the power 7. So let's go back here. What is the among the next 7 randomly selected birth? So if you enter that, it gives us 0.991 if you round it to the 3 decimal place. So that's the probability of having at least one girl, 0.991. Okay, let's go to next problem. Okay, this is the table probability distribution we have given in an experiment. College students were given either 4 quarters or $1 bill, and they could either keep the money or spend it on gum. The results are summarized in the table. So the first question is, find the probability of randomly selecting a student who spent the money, given that the student was given 4 quarters. So here if you look at the first row, student given 4 quarters, 34 of them purchase the gum and 13 of them keep the money. A student given a $1 bill, 18 of them purchase the gum and 30 of them keep the money. So I can just copy this in Excel sheet. So I'm going to just close the previous one and use this one, this data. So as you can see here, the first question is, if you select randomly one student, then okay, if you select randomly one student, find the probability of randomly selecting a student who spend the money, given that. So given that means you're just using the student who got 4 quarters. So as you can see here, 34 plus 13, so this many student got the 4 quarter. So 34 plus 13 is 47. So out of 47, 34 of them purchase the gum, so spend the money. So we already know that we have to focus on this 47. So when we try to find the probability, it's 34 out of 47. Okay, so that's 0.723. So remember, it's given. Given means you just have to focus on that thing. Given that the student was given 4 quarters, so you just have to focus on the first row. You don't have anything to do with the second row here. So the answer is 0.723. 0.723. Okay, find the probability of randomly selecting a student who spent the money, given that the student was given a $1 bill. So one more time, we're just focusing on second column, a second row, because student given a $1 bill. So altogether there are 30 plus 18, which is 48 students who got $1 bill, and out of 48 students, 18 of them spend the money. So that means 18 out of 48. That's the probability, 0.375. 0.375. So as you can see here, whoever got $1 bill, they spend less number of them spend the money than quarters. Okay, so what do the percentage results suggest? We can read this given thing here. A student was more likely to be given 4 quarter than a $1 bill. We cannot say that. A student was more likely to have spent the money than to have kept the money. Okay, a student given $1 bill is more likely to have spent the money than a student given 4 quarter. That is opposite. A student given 4 quarter is more likely to spend the money because their spending probability is 72%, and a student who got $1 bill, their spending probability is 37.5%. That's why this is the right answer. Okay. Okay, problem number 16. Assume that there is a 6% rate of disk drive failure in a year. Okay, this problem, if all your computer data is stored on hard disks, this number 16 is very similar to one of the problem we did before. I think this one. So number 12. This is very similar idea, So I'm going to skip this problem. Very exactly similar to number 12. The same idea actually. Fill in the blanks. Blank probability of an event is a probability obtained with the knowledge that some other event has already occurred. That's called conditional probability. A thief steals an ATM card and must randomly guess the correct 5-digit PIN code from a 9-key keypad. Repetition of digit is allowed. What is the probability of correct guess on the first try? The number of possible code, because it's a 9-digit, so 9 options for the first digit. This is the 5-digit code, so 9 times 9 times 9 times 9 5 times. So what I'm trying to say is that thief has to guess 1 2 3 4 5 digits, and then for each of these digits there are 9 options. So 9 times 9 times 9 times 9, so that many options. So if you use a calculator, which is 9 to the power 5, which is 9 times 9 times 5 times, which is 59,049 different ways. So the answer is here. The number of possible code is 59,000 and 49. 59,049. That many options are available. So what is the probability to get the right answer? It's a 1 out of this. So you can put either integer or fraction. So I'm going to use a fraction here. 59049. When testing for current in a cable with 10 color-coded wires, the author used a meter to test 5 wires at a time. 10 out of 5. How many different tests are required for every possible pairing of 5 wires? This is a combination problem. How many different combinations we can create? 10 out of 5. So this is let's see one more time. It's a 4.4, section 4.4. 1 2 3 4. Okay, it's a combination problem and there is a formula for that. I'm going to show you the formula. This is the formula you have to use. 10 out of 5 out of 10. I think it's yes, 5 out of 10. Yes, 5 out of 10. That's the formula we have to use. 10 factorial over 10 minus 5 factorial times 5 factorial. So how do you calculate that? It's a 10 5 combination out of 10. It's a 10 factorial over 10 minus 5 factorial times 5 factorial, which is 10 factorial divided by 5 factorial times 5 factorial. So if you use your calculator, or you can just simplify, 10 factorial means 10 times, 9 times, 8 times, 7 times, 6 times, 5 factorial, and there is a 5 factorial, so we can cancel that one of the 5 factorial, And again, 5 factorial means it's 5 4 3 2 1. So we can just multiply that here using a calculator. It's a 10 times 10 times 9 times 8 times 7 times 6 on the top, and divided by 5 factorial means it's a 5 times 4 times 3 times 2 times 1. I don't have to write down the 1. So there are 252 different possibility. 252 different possibility. Okay. Okay, so next problem is problem number 20. Winning the jackpot in a particular lottery requires that you select the correct two numbers between 1 and 28, and in a separate drawing you must also select the correct single number between 1 and 17. Find the probability of the winning. So to solve this type of problem, so first of all we have to understand the question here. There are three numbers we are selecting. Probability of two numbers and again one single number, one single. They are independent, so we can say find the probability of two numbers first and times it by probability of one single number using the different methodology. So for finding the probability of two numbers, we need to find out how many different possibilities are there for those two numbers. So to find those two numbers, there are numbers from 1 to 28, so we can choose anything from 1 to 28. So we need to use combination of number from 1 through 28, two numbers from 1 to 28. So we can use we can choose two number from 28 different options. Using the combination formula, it would be 28 factorial over 28 minus 2 factorial times 2 factorial. That is the combination formula. And if we simplify this, it's a 28 times 27 times 26 factorial. 28 minus 2 is 26 factorial. 2 factorial means it's a 2 times 1, so it's actually 2. So this 26 factorial and this 26 factorial we can cancel out. And then if we divide this 28 by 2, that will give us 14. So 14 times 27, 14 times 27, we multiply that. 14 times 27, so 378. The meaning of this is to choose two number out of 28 different options. There are 378 different possibility. We can choose those two number from. So the probability of getting these two number out of this 378 is 1 out of 378 times. For the second case, probability of choosing this one single number, because there are 17 options 1 through 17, the probability is 17. So here the probability of getting one single number is 1 over 17. So if we multiply these two, 378 and 17, so it's a 378 times 17, that gives us 6,426. So it's 1 over 6,426. So the probability of winning that jackpot is 1 over 6,426. Keep in mind, we always have to double check our answer. That's right, 6,426. Okay, so next problem. A corporation must appoint a president, chief executive officer CEO, chief operating officer COO, and chief financial officer CFO. It must also appoint a planning committee with 4 different members. There are 17 qualified candidates. An officer can also serve on the committee. So how many different ways can the officer be appointed? To answer this question, first of all, I would like to take you here the difference between permutation and combination. Permutation means position matters. Combination, position does not matter. So when we try to deal with the situation like CFO, CEO, they are the position. We cannot alter their position. That's why to select the officer, we have to use the permutation formula. And for the committee members, because the position, the order doesn't matter, arrangement, you know, uh, the, the we can rearrange them, you know, one position to another. So rearrangement of the same member result in the same committee. So in the combination, uh, you know, we can go from one way to another way. Meaning here, let's say ABC and BAC, they have the meaning, it matters. But here ABC and BAC, they are same thing. You know, the order doesn't matter. So this is the difference you have to understand for the permutation and combination. And based on the situation, we have to use the formula for the permutation, which is what is that? Formula for the This is the formula for the permutation. So if you have to choose r from n options, it's n factorial divided by n minus r. And for the combination, this is the formula for the combination. So we are going to use this formula while solving this problem. The first case is how many different ways can the officer be appointed? Because officer, for this officer, the the position matters, the order matters. That's why we're going to use the permutation. So 4 out of 17 qualified candidates. So when we try to answer this question, we have to use the permutation. 4 out of 17. So it's a 17 factorial over 17 minus 4 factorial, which is, if you expand this, 17 times 16 times 15 times 14 times 13 factorial. 17 minus 14, 4 is also 13 factorial. I can cancel this and I can just multiply these numbers here, which is 17, let's say 17 times 16 times 15 times 14. So 57,120. So out of this 17 candidate, to choose this 4 officer, there are 57,200 and 57,120 different options. That's the answer. 57,120 different ways we can select those 4 officers. But for the committee members, because this arrangement, the order doesn't matter, so we have to use combination formula. So the combination formula is now, it's a 17, 4 out of 17, but the combination formula is, it's a 17 factorial divided by 17 minus 4 factorial divided by 4 factorial. So this is the same number and divided by 4 factorial. 4 factorial means 4 times 3 times 2. So this is the same number from the top. So this is the same number, like 57,120, and divided by 4 factorial, which is 4 times 3 times 2, which is 4 factorial means it's 4 times 3 times 2 times 1, it's a 24. So divide this number by 24, and that gives us different combination, 2,380 different combination. So to select the 4 committee member, we can use them 2,380 different ways. 2,380 different ways. Okay. And there is a one last part here. What is the probability of randomly selecting the committee members and getting the 4 youngest of the qualified candidate? So if you just try to find out the 4 youngest, there is only one group with the youngest. So it's 1 out of 2,380. So it's a 1 out of 2,380. Okay, so next question is determine whether the value is a discrete random variable, continuous random variable, or not a random variable. So first of all, if you check your notes, you can find out the meaning of discrete random variable and then continuous random variable. Discrete means has a collection of values that is finite or countable, and continuous means it's infinite and not countable. Discrete could be infinite, but you can count it. Okay, and random variable, it should be a number. So here the first case is the weight of a T-bone stick. So weight is continuous because we don't have from, let's say, from 1 pound to 2 pound, there are infinite many different possibility. So it is a continuous random variable. Is the number of hits to a website in a day a discrete random variable or continuous? It's a discrete. It's a discrete random variable because you can always count it, like 1,000 hits, 2,000 hits, 5,000 hits, something like that. Is the gender of a college student? Gender, it's not a number, so it's not even a random variable. Is the number of people in a restaurant that has a capacity of 200 a discrete random variable? Yes, because it's a fixed number from 0 to 200. It's a discrete random variable. Is the amount of rain in city B during April? It's continuous because it's amount. It could be infinitely different possibility there. It is a continuous random variable. And finally, the number of people with blood type A in a random sample of 19 people. It's a discrete random variable. It could be 1, 2, 3, 4 up to 19. That's why it is a discrete random variable. Let's go to next problem here. This is the table we have given between events and its corresponding probability, which is probability distribution table. College students are randomly selected and arranged in groups of 3. The random variable X is the number in the group who says that they take one or more online courses. Determine whether a probability distribution is given. If a probability distribution is given, find its mean and standard deviation. Keep in mind, any distribution is called probability distribution. There is a requirement for that, there are 3 requirements. So the one is it should be numerical value, not a categorical. Sum of the probability should be 1, and finally the probability of each event should be in between 0 to 1. So these are the 3 requirements it has to satisfy. If you look at this table here, you can see this is the number and the probability. Now we just have to add all these probabilities. So I'm going to use this Excel sheet here to add this probability, this data, and when I add this probability here, sum, it's from this number to this number. If I add them, it's 1. So that's correct. So it's 1. All the events, as you can see here, the value of X, the random variable is a number. Probability of each of these random variable is in between 0 to 1, and then sum of the probability is 1. So it satisfies all 3 criteria to be probability distribution. So the answer is yes. Okay, so if it's yes, then find out the mean. If it's a probability distribution, there is a formula for finding the mean, and that is sum of x times px, and there is another formula for finding the, what is that called, standard deviation. So there are 2 different ways you can calculate this mean and standard deviation, by using this formula using manual way, or you can also use your calculator. For that, first of all, you go to your calculator. I'm using calculator here. I'll go to stat, and I'm going to use this place to store this information, this list here, 0, 1, 2 and 3, 0, 1, 2 and 3. I have to delete this fourth one. Okay, so now it's also delete, and I'm going to update. I use this calculator to calculate some of other problems, so this data were already here, so I have to update this data. When x is 0, the probability is 0.107. Enter 0.355. Enter 0.389. Enter 0.149. So that's the data we have. Now we're going to use this data to find the this mean and standard deviation by going here. Go to stat, go to calculate, and go to the first option, one variable stat, enter it, and then use data from list 1. If you use second and 1, that takes the data from list 1. Use comma and data from list 2 as well, so second and 2, and now hit enter. That gives you the mean. X bar stands for the mean, and sigma x here it stands for the standard deviation. So our calculator is going to calculate this value for us if you don't want to do it manually. So the mean is 1.58, so it's a 1.6. That's the answer. And the standard deviation is what is the standard deviation here? It's a 0.9 because we have to round it to the one decimal place, 0.9. Okay, next question, very similar question. We need to find out either this represents probability distribution or not. As you can see here, the value of x, as you can see here, the value of x, it's a categorical, it's not even random variable. So the answer is no, because the numerical value of the random variable x are not okay. No, the random variable x is categorical instead of numerical, so that is the correct option. Because it's not probability distribution, we cannot find mean and standard deviation. The table does not show a probability distribution. That's a option we have. Again, the very same option we can choose. And now let's go to the next problem. We have given probability distribution. The data for this data, which is the probability for the California Daily 4 lottery. The player select 4 digits with repetition allowed, and then random variable x is the number of digits that match those in the same order that they are drawn for a straight bet. Use the range rule of thumb to determine whether 4 matches is a significantly high number of matches. To answer this question, first of all, you have to understand that this rule, range rule of thumb. If something is greater than mu plus 2 sigma, that's significantly high values. Something is less than mu minus 2 sigma, that's significantly low values. So we need to find out the mean and then standard deviation first to answer this question. So we're going to do the same thing. I'm going to use calculator one more time, and I'm going to use this data here. So I'm going to go to stat and number 1, edit, and I'm going to edit this list. Let's start with the list 1. There is a 0, 1, 2, 3, and then there is a 4 as well. So list 4. Okay, now go to list 2. For 0, the probability is 0.657, and for 1, the probability is 0.297. For 2, it's a 0.042. For 3, it's a 0.005, and for the last one, for 4, it's a 0. So that's our data. And now we're going to go to stat one more time and go to calc, and then go to first option. And now we're going to use data from list 1, which is second one, comma, data from list 2, which is L2, and then hit enter. That gives us this average and then standard deviation. Now to use this rule, we need to find out so let's go back here, select the correct choice below. Significantly high number of matches are significantly high number, high number, high number. So to have the significantly high number, we need to calculate mu plus 2 sigma to so here the mu, which is average, is 0.395. So I'm going to use this 0.3956043,956. You don't have to use all these digits, you can round it. And plus I'm going to use this parentheses because I need to find out 2 times this standard deviation, which is 0.594127656. And if I do that, it gives me 1.58. If you round it to the 1 decimal, it's a 1.6. So significantly high, this 4 is so the question is, use the range rule of thumb to determine whether 4 matches is significantly high. Yes, because 4 is higher than 1.58, so it's significantly high. So significantly high number of matches are 1.5 or more. So significantly high number of matches are 1.5, 1 rounded to the 1 decimal place, so it's a 1.6 or more. Since 4 is less than this value, okay, this is not the right option. Okay, the option should be significantly high number of matches are 1.6 or more. Since 4 is at least as high as this value, 4 matches is significantly high number of matches, so that's the right option. Okay, next question. We have given this data here, probability distribution, and now this is the data for a group of 8 births from 8 different sets of parents. The random variable x represents the number of girls among 8 children. So by looking this data, we need to answer this question. Find the probability of getting exactly 6 girls. As you can see here, exactly 6 girls, the probability is 0.118. 0.118. That's good. The second one, find the probability of getting 6 or more. So you have 6, 7 and 8, you have to add all these 3. Okay, so if you add it manually, so as you can see here, it's a 0.118 plus 0.039 plus 0.004. That gives us 0.161, and do not round it, so 0.161. So that's 6 or more. Finally, which probability is relevant for determining whether 6 is a significantly high number of girls in 8 births? This is 6 or more. So part B is this number is greater than 0.05. So the result from part B, since it is the complement of result, the result from part B, since it is the probability of a given or more extreme result. So this is the right answer. Is 6 a significantly high number of girls in 8 births? So if we go back here, any number, where is that? Any number, if probability of x or more is less or equal to 0.05, that's called significantly high. But in our case, it's not less than 0.05, it's 0.161, so it's not significantly high. So the answer is no, since the appropriate probability is less than 0.05, greater than 0.05, so it is not significantly high number. So since this number here, the part B is greater than 0.05, that's the reason this is the right option for us. Okay. Determine whether the following procedure results in a binomial distribution or a distribution that can be treated as binomial. So we need to find out either this is the binomial or not. By applying the 5% guidelines for cumbersome calculation, If it is not binomial and cannot be treated as binomial, identify at least one requirement that it is not satisfied. In a Pew Research Center survey, 1,875 subjects, the ages of the respondent are recorded. Is it binomial probability distribution? So let's go to this section, binomial probability distribution, and check what is the binomial probability distribution. A binomial probability distribution results from a procedure that meets these four requirements. The first one is the procedure has a fixed number of trials. Number is fixed. The trial must be independent, and each trial must have two outcomes, and then probability of success remains the same in all trials. So in this case, it surveyed 1,875 subjects. The ages of the respondent are recorded, so it's not binomial because there are no two outcomes. Okay, it is not binomial. It is not binomial because there are more than two possible outcomes, and the trials are not independent. Okay, this is the right option. It is not binomial because there are more than two possible outcomes. Okay, next question. 39.6% of consumers believe that cash will be obsolete in the next 20 years. Okay, assume that 6 consumers are randomly selected. Find the probability that fewer than 3 of the selected consumers believe that cash will be obsolete in the next 20 years. So here we can use a calculator, or we can use Excel for finding this answer. So to answer this question, we can use calculator or we can use Excel. So to use the calculator, you have to go to second, and this VARS, the second of this is distribution, and then if you go to option A, which is binomial cumulative distribution, it takes the first one, how many trials are there. Assume that 6 consumers are randomly selected. Find the probability that fewer than 3 of them selected consumers. So 6 out of 6, the probability we have given is 39.6, so we have to put that probability 396, and then we want to find out a binomial distribution for 3, fewer than 3. Fewer than 3 means it could be 0, it could be 1, it could be 2. So this function BinoMCDF calculates up to like 2 or 3 or 4 or 5, whatever number you want to calculate. So in this case it's up to 2 because we want fewer than 3. That's why I choose 2. So if you just hit enter, that gives you binomial distribution. Use the binomial distribution function and it gives you the probability. The probability is 0.5526, and you can calculate the very same thing using Excel, and there is a function called, just hit enter, equal sign and binom.dist, and then parentheses, number of trial is, we want to go up to 2, comma, total number of trials 6, probability of success is 0.396, and then because it's cumulative means it calculates the probability for 0, 1 and 2 and add them all. So that for that we need to put 1, and then that gives us 0.552614. 0.552614. So that's the same number. So if you round it to the 3 decimal place, it's a 0.553. 0.553. Okay, assume that when human resource managers are randomly selected, 47% say job applicants should follow up within 2 weeks. If 8 human resource managers are randomly selected, find the probability that at least 3 of them say job applicants should follow up within 2 weeks. So one more time, we can use the same formula for the probability, at least 3. So we can go here and we can use the same formula, equal binomial distribution and then in this case number of trial is at least 3, so we can put 3 comma the total number is, I am trying to, total number is 8 out of 8, so 8, and then probability given is 0.47, and it's a cumulative, so we need to use 1, so that is 0.430621, and if you round it to the 4 decimal place, it's a 0.43. Okay, I'm doing mistake here, because it's asking me at least 3, so at least 3 means it could be 3, 4, 5, 6, 7, 8. So actually we have to find out the complement. So I was finding up to 3. This is up to 3. We are not looking for up to 3. So what do? We look up to 2. So this is up to 2, and complement of up to 2 is at least 3. So if I subtract this value from 1, that would be our answer, because at least 3 means it could be 3, 4, 5, 6, 7, 8, and the complement of that at least 3 is at most 2, which we calculated here using this binomial distribution formula. 2 out of 8 with this probability, and then this is the complement. So 4 decimal place is 0.8125. 0.8125. Okay, assume that hybridization experiments are conducted with peas having the property that for offspring there is a 0.75 probability that a pea has green pods. Assume that offspring peas are randomly selected in group of 36. Complete A through C. Find the mean and standard deviation. So in this section, to find the mean, there is a formula. What is that? Mean is mean is number of trials times probability. So it's here probability is 0.75, n is 36, so the mean is, it's 36 times 0.75, which is 27. So standard deviation, one more time, the standard deviation formula is square root of n times p times q. So we can just use n is 36, p is 0.75, q is 1 minus p because it's complement, so 1 minus p is 0.25, and if you integrate and take the square root means second, and then this one, and then you have to put answer inside here. So square root of the answer, that is 2.59. Let's look at here, 1 decimal place, 2.59, so it's a 2.6. Finally, use the range rule of thumb to find the value separating results that are significantly low or significantly high. The values of this number of p's or fewer are significantly low. So for the significantly low, we need to always calculate mu minus 2 sigma. So mu minus 2 times this value. So I'm going to do that. Mu is 27 minus 2 times standard deviation, which is 2.6. So anything less than this is significantly low. So values of 21.8 and less p's or fewer are significantly low. And values of, and for the high you have to do the same thing, but instead of minus you have to plus 2 times 2.6, and then that gives us 32.2. Anything greater than 32.2 is significantly high. So now, is a result of 31 p's with the green pods a result that is significantly high? No, it's a less than 32.2, so it's not significantly high. The result is not significantly high because 31 p's with the green pod is less than this number, 32.2. Okay, so that's you know test to review.